All right, hello ALEKS students. So this is another ALEKS topic that's called drawing a skeletal structure from a simple condensed structure. And in this topic, we get to use the new drawing tool, which is really nice actually. So we'll talk a little bit about that. So the main concept in this topic is really understanding what we call skeletal structures. They're also called line structures, as we can see here. And the main take-home message about skeletal structures is that carbons and hydrogens become quote-unquote invisible. They are just represented by the lines that we draw. And we assume that every time we've got something like this, the end represents a carbon if there's no label on it, and the hydrogens are just assumed, the proper number of hydrogens are assumed to be there. So this line right here actually would represent a CH3 right here and a CH3 right here. That's sort of what this represents. So I'm gonna delete that for now. And if I wanted to start drawing this, essentially I'm just gonna start doing that and then fill in anything that's not a carbon or hydrogen by writing in the label, the proper label. So let's go ahead and do that. So I'm gonna just start by drawing my first structure here. So here, this would represent this CH3. This right here would represent this carbon. Then I'm going to draw another line. So down here I would have this nitrogen. And I'm going to focus on this, what I would consider to be sort of the main chain first, and then I'll draw in these other substituents, these other groups, after I've sort of gone through this main chain. So let's go back here. This is a CH3. This is this carbon. This is this nitrogen. We are going to have to change the label. Why don't we just do that right now? So if I click on this, I can actually just change that to be this nitrogen. That'll help us, keep us oriented. Keep drawing. So here I've got this carbon, then I've got this CH2 here, and then this would be my CH3 at the end. And for these, I don't need to change. I don't need to add any labels. We are assuming that the end of this line here is a carbon, and then it has the proper number of hydrogens to essentially fill its octet, which is 3 here, which would be 2 here. This is another carbon. Again, we don't have to label it, but we do need to draw in this double bond to this oxygen. So if I draw 2 bonds, and then here I'm going to put in the oxygen, that represents this right here. Off of this nitrogen, we've got another CH3. Because it's CH3, I can just draw like this. I can just leave that bond. At the end of this line, we assume that there's a carbon. We assume that carbon has the right number of hydrogens around it, which would be 3. That's all we have to do. And then lastly, we need to put in this double bond and another oxygen here. And that's it. So this is basically the skeletal structure of our molecule here. We'll do another one just for a little bit more practice, but let's go ahead and check this. And we got it right. That's good. So here we've got another one. And again, I'm just going to start by drawing the main chain first, and then we'll add in any groups that we need to once we've done that. And I like to sort of do it, in this I don't know what in this stepwise manner, with these angles, just because that's sort of how we would typically do it. It makes it a little bit easier. So this would be this NH2, and I'm going to actually have to put that in this way. So I need to switch the order here. And this is a good little conversation piece, because if I did it this way, it's a little bit unclear where this bond is going to. Now, if we have experience with organic chemistry, then we would know that this is bonded to the nitrogen. Hydrogen's not going to have multiple bonds to it, but it is better. It is much more clear when we draw it this way, where this nitrogen is then bonded to this carbon. So good little trick there. Just by choosing these, I can switch the order and choose the one that I need. Here we've got a carbon. Again, the carbons and hydrogens we don't need to worry about when the hydrogens are attached to the carbon, I guess. Here's our CH here, and then this I would say would be our CH2. Then we need another CH3 here. And then off of, let's make sure we do this right, off of this one, I'm going to have this other CH3. So this NH2 here at the end, this is the CH2 here, this is the CH here, this is the CH3 up here, and then a CH2 here and CH3 here. So that's it. That's all we need to do. And take-home message is we want to make sure that each step along the way, each time that there's a bend, that represents a carbon. The end of the chains also represent a carbon as well. So we'll go ahead and check that. and we've got it right. So hopefully that's helpful. Thanks very much.